Theorem 10 is going to be our first example of a proof by contradiction, and this is a really famous and useful strategy for proving theorems. So what my goal here right now is to emphasize and bring out what the pieces are that make a proof by contradiction, how you set it up, what the structure is you use. So the first thing you do in this proof, and in pretty much every proof, the very first thing you do is you name the hypothesis. So that's the if part. And in this case, how it's phrased, that's not super obvious, but my if part is if I have two distinct lines. So it's the part that come before the verb intersect. I am given that I have two distinct lines. Now, when I name this hypothesis as part of the proof, I don't just want to say given two distinct lines. I want to also take the opportunity to name them. So I like to use the word let when I am naming things. So I am naming two distinct lines, AB and CD. Having names for the things in your hypothesis makes it easier to write theorems and write equations about them so that you can prove something. All right, now the next thing I'm going to do, because it's going to be a proof by contradiction, is I have to identify the conclusion. So the if part was that I have two distinct lines, and the conclusion is they intersect in at most one point. So a thing to recognize is that you can take this statement that they intersect in at most one point, and you can turn that into a statement of something that doesn't happen. So saying that the intersection is at most one point is the same thing as saying they can't intersect in two or more points. And anytime you can write that conclusion with a can't, that is part of your realization, maybe a proof by contradiction would be good here. Because the next thing you have to do is you have to suppose that the theorem is false. All right? So if the theorem says they can't intersect in two or more points, then we have to suppose that they intersect in two or more points. And if they intersect in two or more points, then that means there's at least two, and I can name them, because remember, naming things helps you prove stuff. So I'm going to name those points, two of them, that are on the intersection. Now I need to find a contradiction. It has to be a contradiction with something I already know is true. So, in fact, I'm pretty sure it's got to be a contradiction between these two lines being distinct. So we got to somehow prove that those have to be the same lines. And, of course, that's why we proved Theorem 9, is so that we could say that they are the same lines. So, X and Y are on the line AB. And that means that the line AB also is the same, can be named the line XY. And X and Y are on the line CD, so I can rename the line CD as the line XY. And so I have the transitive property of equality. So the transitive property says if A equals B and B equals C, then A equals C. So I have AB equals XY and CD equals XY, and that means AB has to equal CD. All right. That's my contradiction. It is contradicting the part of the hypothesis that said those lines were not equal. So that's a contradiction. And part of a proof by contradiction, part of making this proof, is you have to state that it's a contradiction. This contradicts the assumption that the lines are distinct. Now, once you have that contradiction, what you get to do is you get to go back to where the suppose statement was, the one where you made an assumption. Change colors again. So when I get this contradiction, I go back up to where I said suppose, and what it means is that that supposition is false. So I can say, therefore it is not true that they intersect in more than one point. And if it is not true that they intersect in more than one point, then they have to intersect in at most one point. And so that's how you finish your proof by contradiction.